Hi, welcome to section 5.2 and 5.4 notes with chapter 5. So the main part of this chapter is really understanding these four words that we're going to go over today: angle bisector, perpendicular bisector, median, and altitude. You want to be able to identify those, know the properties about them, so that you can set up true equations involving those properties. So the first one we're going to talk about is angle bisector. That's something we've already talked about so far in geometry. Again, bisect means cuts in half. And what is it cutting in half? An angle. So if it's cutting an angle in half, then therefore you should see two congruent angles, which you can see in this picture right here, here, and here. Those two angles are congruent because, like it says right here, AF is an angle bisector. I think of an angle bisector is kind of like a knife cutting the angle in half. If we fill in these words up here, it says that it's a ray that divides an angle into two congruent angles. Okay, and every triangle has three angle bisectors. So technically I could draw an angle bisector through angle E, another one through angle D, but it just would get the picture really messy, so we don't usually draw all three. If it helps you to write up at the top here, what this means is, some people like to say cuts in half, or what I would be looking for in the picture is that there are two congruent angles. Okay. Another key thing about an angle bisector is that it must come from a vertex. Okay, we're again talking about four different wording things here. Three of them must come from a vertex, which is like vertex A, but one of them does not have to come from a vertex. It can, but it doesn't have to. So that's just another kind of key property to remember. Okay, let's go ahead. Changing the size here. Okay, next one I want to talk about is a perpendicular bisector. So again, if you think about perpendicular means, that's something we've already talked about this year. It means a right angle is formed, which I can see right here in the picture of the right angle. And bisect means, again, cuts in half. But in this case, it's cutting a segment in half. I know that a segment's being cut in half because I see these two congruent marks here. So I therefore know the G has to be the midpoint, which is right in the middle between A and D. If I fill in the blanks here, it says in a triangle, a line, segment, or ray that passes through the midpoint of a side and is perpendicular to that side. Every triangle has three perpendicular bisectors. And again, it's showing me that GH is a perpendicular bisector. So a couple of key things about that. One being that perpendicular means I should see a right angle in the picture. And bisect means that something is getting cut in half. And in this case, a segment is getting cut in half, so it's congruent on each side. So I should see the two congruent marks on the segment. Okay, and this one doesn't have to come from a vertex. Okay, it can come from a vertex. I'll show you a case where it can. Like if this is an isosceles or an equilateral triangle, and I went to draw the angle bisector, then again, it's going to be perpendicular to a side, and it's going to be congruent on each side here. And in this case, it is coming from a vertex, but again, like in this picture, GH right here does not have to come from a vertex. All right, next one is median. If you think of the word median in everyday life, I think of like the median down the middle of the road, and I think of middle. So in this case, if I look at the picture, I can see that coming from point A to point D, D is right in the middle of B and C, and I can tell that it is because of these congruent marks right here. Okay, so if we fill this in, a segment whose endpoints are a vertex of a triangle and the midpoint of the side opposite the vertex. Every triangle has 3 medians. So again, median means middle or hits at the midpoint, and this one must come from a vertex. Okay, just like the first one did. All right, last one is an altitude. If you think about what altitude means, I think of it as like a height, like a plane is flying at a certain altitude. We're talking about how high it's flying. But one key thing to remember is that if we're measuring a height, it has to form a right angle with the ground or the base. Okay, so when we're speaking of altitude, think right angle. Okay, which you can see in some of the pictures here. If we go and fill in the blanks first, it says an altitude of a triangle is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. Every triangle has 3 altitudes. So if we see this one up here, that is a right triangle, triangle DEF. Well, the sides of the right triangle are altitudes from D to line EF, then DE is an altitude. From point F to line DE, that side of the right triangle is an altitude. If I want to draw the third altitude, it would be something like that, that forms a right angle. Okay. If I look at this triangle over here, then I can see that LN is an altitude. Again, coming from point L to line KM, that's representing the height or the distance between that segment and that line. And then this last one right here, this is an obtuse triangle. There's no way I can draw a line from point A to BC inside the triangle and get a right angle. So that's where you can see that this line was extended out. And then from point A, I can drop down and get a right angle distance, which represents the accurate height between point A and line segment BC. So sometimes an altitude might be a side of the triangle. Sometimes it might be on the outside. Sometimes it might be on the inside. So you just kind of have to pay attention there. All right, we're not going to do this construction for time's sake. So we're going to move on down to these theorems. So for the theorems, the perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant. And that is just a fancy word for equal distance. I'm not sure why they made a new word of that. But it's equidistant from the endpoints of the segment. So in this example, it says X is on the perpendicular bisector of segment AB. So just meaning that if point X is on the perpendicular bisector, then that means it has to be the same distance away from A as it is from B. And therefore, these pieces are congruent to each other, which we can tell by the 3s that they are. Okay. The converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So again, here it's saying if X is the same distance away from C and D, then X must be on the perpendicular bisector. And if it is a perpendicular bisector, then I therefore know that's a right angle and that these 2 segments are congruent. Okay, now this page of the notes is basically just kind of practice for what the homework looks like. This is really similar to the homework worksheet. So this first example is basically what the mini quiz looks like. Example 1, where you're just identifying the median, altitude, perpendicular bisector, and angle bisector on this picture. So first one is median. The things I'm looking for, I'm going to give a few reminders here, is that it must come from a vertex, and it must go to the middle or midpoint of the opposite side. So from the vertex to the middle or midpoint of the opposite side, I can tell that by these congruent marks. Then I know that F Gotta see what letter that is now that I covered it up. FJ. So let me erase that so you can see the J. But FJ is a median. Okay. Now, if we look at another one, an altitude, remember it must come from a vertex. And I need to be seeing a right angle. Okay, so coming from a vertex, forming a right angle with the side, then that represents a altitude, kg. All right, if you have these written opposite from me, like in this case, JF or GK, that would be fine as well. All right, next up is a perpendicular bisector. So again, for that means I'm looking for the right angle and I'm looking for the bisect part, which is, basically two congruent parts of that segment. Okay, so if I look for that, and remember this one can come a vertex, but doesn't have to. So in this case, HJ is the perpendicular bisector because I see this right angle, I see these congruent marks, so it must be a perpendicular bisector. And then the last one, I'll go back to blue, is an angle bisector. So that means it's like a knife cutting an angle in half. It must come from a vertex and it must cut angle in half. I'm kind of running out of room here. Okay, so I can see these congruent marks on the angle here. So therefore, I know that this line or ray must be an angle bisector. So in this case, starting at I and going to E, I'm going to actually name that as a ray. Okay. So again, those are what the mini quiz will look like. It'll just be more of a multiple choice type question, but it's identifying those. Number 2 is just drawing and naming all the medians. So from this vertex, I lost my spot. Okay, here we go. Sorry about that. I clicked on the wrong thing. So from F to I is one median. Okay, from a vertex to the middle or midpoint of the opposite side. From G to J is another one. And the last one goes from E to H is our last median. So again, from a vertex to the middle or midpoint of the opposite side. Now on example 3, it says find X if segment BD is an altitude. So if you look at the picture, BD definitely doesn't look like an altitude, but it's telling me that it is. So I have to mark something on the picture based on it being an altitude and then use that to set up a true equation. You can see a ton of expressions on this particular picture, so you're definitely not going to use all of them in equation. But if I know that this BD is an altitude, then I know that this should be a right angle and that should be a right angle. So if I think a true equation to write based on that, then I can set up the equation that says 9x plus 27 is equal to 90. Okay, so go ahead and write that equation and then solve for x. So if I do that, I've got 9x plus 27 is equal to 90. If I go ahead and subtract 27 from both sides, I end up with 9x is equal to 63. And if I go ahead and solve for that, dividing by 9 on each side, I end up with x is equal to 7. Sometimes they might ask you to plug back in to find something else, but in this case, that's all it's asking for is to figure out what x is. It doesn't like a 7. Let's try that again. There's the 7 and there's the circle. Okay, So now I'm going to erase what I marked on the picture because that may not apply to the next question. So in the next question, it says, find x if segment BD is an angle bisector. So BD was an angle bisector. I know BD would be a knife cutting angle ABC in half. So I know these two angles would be congruent. So therefore, I can set these two expressions equal to each other. Okay. If I go and subtract 2x from both sides, then I end up with x. So let me show my work on that. I end up with x minus 1 equals 7. If I go ahead and add 1 to both sides, then I can solve and get x equals 8. All right. Next one is a median. So again, median means middle. So if I go ahead and erase the markings I have up here, and if I think about BD being a median, then that means it goes from vertex B to line AC right to the middle, meaning D is the midpoint or middle. So I would know this piece is congruent to this piece. So I should be able to set those equal to each other. 7x minus 3 equals 4x plus 9. And then I can do a true equation. That's my true equation. Now I can solve from there. So if I go and solve from there, I can subtract 4x from both sides and get 3x minus 3 equals 9. Writing's not doing very well here. Now if I add 3 to both sides, I end up with 3x equals 12. And then again, if we go ahead and divide by 3 on both sides, then I end up with x equals 4. Okay. Now, last little bit are some of those theorems we talked about under the construction we didn't do. So in this case, it says, from the information given in the figure, how is TV related to SU? Well, I can see this right angle symbol, and I can see these congruent marks. So I therefore know that TV would be a perpendicular bisector. I'm going to do symbol for that, perpendicular bisector. Remember, upside down T stands for perpendicular. Of SU. Okay, and then if it's a perpendicular bisector, we can answer these pretty quickly and easily. TS then would have to be 3.7 also, because T is the same distance away from U as it is from S. Okay, for UV, again, I can see if SV is 7.9, then UV is also 7.9. And then on number 9, SU, I can see in the picture, SU is this whole length across. Well, if I know already know RU is 3, then I know over here has to be 3 since they're congruent. And so I'm just adding up 3 plus 3, which is equal to 6. All right, so that's it for section 5.2 and 5.4. Thanks for joining in, and I will see if you have any questions when I see you in class next.